Up until now, our universe has been governed by two laws: general relativity for really big things and quantum mechanics for really small. But when we try to combine these two together, crazy things begin to happen. Our physics just doesn't make sense. But it has been a long dream for physicists to have a theory which can combine everything together. A theory of everything. On the search of the ultimate theory of everything, we might have finally stumbled upon a solution. It is the string theory. String theory tells us that if we zoom enough inside the matter that makes us, even further than the standard model of physics allows us to, we would see tiny strings vibrating. Just like the guitars of a string can be plugged in different ways to produce different sounds, the strings of string theory can produce different particles on different vibrations. This idea has huge implications. The formation of particles like quarks, photons, bosons, the force-carrying particles can now all be boiled down to the way these strings vibrate. String theory can even incorporate gravity with the other fundamental forces. This is something which the physicists haven't been able to do with any other theory up until now. There is another mystery string theory gives rise to. The math of the string theory suggests that there may not be only 4 dimensions in which we live. There may be 10 or 11 dimensions. But why don't we see them? We don't see the extra dimensions because they are curled up at the Planck length. This is like seeing a straw from 1 kilometer away and not being able to tell it has thickness. It just appears as a single string. So when we see objects from far away, they tend to lose dimensions. So at the Planck scale, these dimensions are curled up inside what is called a Calabi-Yau manifold. It is believed that the way these spaces are curled up upon each other gives strings and hence particles their different properties. Vibrating inside these dimensions, strings form the reality itself. Up until now, only the math of this theory works. Although it works perfectly, it is not enough. This is the main problem of string theory. It can't be tested, ever. Until we come up with a very clever way, the only way to confirm the theory's existence is to observe the strings directly. But it is impossible as the strings are the size of the Planck length. That is 10 raised to the power minus 33 centimeter. To give you a perspective about how tiny that is, imagine stretching an atom to the size of our solar system. The string inside it will just be a mere tree on the planet Earth.
So even after all of its problems and limitations, string theory is still our best bet to know everything about our universe. Scientists are optimistic that they will find a way to prove the theory's existence. But until then, all we can do is keep on connecting dots with strings.